In some corrective maintenance tasks, the refrigeration technician must replace the compressor or capillary tube. In these situations, knowing the cooling capacity of the system can be essential. This raises the question: what is the cooling capacity or power of a 1/6 HP compressor that uses our 134A refrigerant gas in refrigeration and freezing applications? Let's begin by stating that the cooling capacity of the compressor depends on several factors, with the main one being the evaporation temperature, which varies according to the equipment application. To determine how much load a compressor can cool, we will use the following units: watts, BTU per hour, and kilocalories per hour. And we'll follow these steps. 1. For the calculations, we will use our online simulator. First, we select the refrigerant gas used by the compressor, in this case, our 134A. 2. Then, we set a superheat of 5 degrees Celsius at the evaporator outlet. Remember, superheat is the temperature increase of the refrigerant between the evaporator's inlet and outlet. 3. To calculate the condensation temperature, we add 10 degrees Celsius to the outdoor ambient temperature. 4. As for subcooling, we set it to 5 degrees Celsius. Subcooling is the temperature decrease of the refrigerant in liquid state at the condenser outlet. Remember that in the video description, you'll find the link to our simulator. 5. Now we need to calculate the system's coefficient of performance, or CP. We start with an evaporation temperature of minus 20 degrees Celsius, which gives us the following CP. 6. Remember, the CP of a refrigeration system is the ratio between the amount of heat removed and the electrical power consumed by the compressor. 7. In this case, a 1/6 HP compressor is equivalent to 124 watts. Using the COP provided by the simulator, we calculate the cooling capacity by multiplying this value by the electrical power. This gives us the cooling capacity of the compressor under the previous conditions, as shown on screen. 8. Now on screen, you can see the compressor's cooling capacity in several power units. 9. Next, let's consider an evaporation temperature of minus 10 degrees Celsius, which results in the following CP. A 1/6 HP compressor corresponds to 124 watts. Again, the cooling capacity is obtained by multiplying the COP by the compressor's power, producing the following results. Remember, you can access our simulator using the link in the video description. 10. Now on screen, you can see the compressor's cooling capacity in various power units. 11. Finally, we can generalize and say that a 1/6 HP compressor using our 134A refrigerant is frequently used in systems with a total capacity of 200 liters, typically consisting of a refrigerator between 150 and 160 liters, plus a freezer between 40 and 50 liters.